I still remember the day my car's bumper got damaged. There I was, staring at the broken pieces, feeling a mix of frustration and helplessness. I'm no car expert, and the thought of dealing with repair shops was daunting. The hours spent waiting, the uncertainty of not knowing the cost, and the hassle of explaining the problem without knowing the technical jargon, it was overwhelming. In those moments, I dreamt of a simpler solution. Picture a virtual garage where you just type in the issue and get instant professional assistance. A platform where you have the choice, engage in a chat with our AI mechanic team, or simply upload an image of the damage. The AI then automatically analyzes the image and swiftly generates an offer for the spare parts and repairs, all communicated through an email. In this course, you'll discover how to establish autonomous agents and link them with web-based chats. We'll take you step by step through creating a garage website capable of accepting and automatically analyzing images for damage. You'll be building everything from the ground up, and as a bonus, you'll receive access to all the source code, giving you a solid foundation for your own project. In this video, we are setting up an AutoGen team from scratch that is designed to analyze car damage based on images. We'll configure agents who will identify the car brand and the necessary spare parts from the image. Additionally, we're integrating an agent that will eventually be capable of checking part availability in a database. Another agent in our setup will be tasked with composing an email to the customer, completing the end-to-end process. As always, we begin by first creating a virtual environment to keep the dependencies cleanly separated. Then we install AutoGen and Pillow, which we need for image recognition. Next, we create a file named app.py and import AutoGen. After that, we set up the configuration for the AutoGen agents. We load this configuration from a JSON file named OIconfig list. This file must be located in the root folder. In the configuration, we specify the model as GPT-4 Turbo, the most powerful current model from OpenAI, and we provide our OpenAI API key, which we find in the OpenAI member area. Subsequently, we create a second configuration for our GPT-vision agent. The special feature here is that we use GPT-4 Vision Preview instead of GPT-4 Turbo. This enables us to process and evaluate images later on. The great thing about AutoGen is that every agent can have its own underlying language model. Then we create a user proxy that can execute functions and manage the process. The user proxy in AutoGen acts as a bridge, channeling tasks and requests from users to the right agents within the system. The next assistant is the inventory manager, responsible for managing the inventory and providing information about the availability and price of spare parts. In the next part, we'll link the agent directly with a database. Until then, as we set up the actual data connection, it will default to responding that everything is available. Additionally, it also needs a configuration, and we specify the standard GPT-4 Turbo configuration. Our second assistant is the customer support, responsible for composing emails to customers and later the actual sending of these emails. In AutoGen, we can map any action achievable with code to these agents through function mapping. This capability allows us to use code for practical tasks like sending real emails or storing prepared emails in Google Sheets. Before the agent starts composing, it must wait for confirmation from the inventory manager that the parts are available. Since this is the last step in our process, we also tell it to respond with terminate when it's done with the email. Next, we create the group chat which should include all agents, meaning the user proxy, the inventory manager, and the customer support agent, and we start with an empty messages array. Then we create a group chat manager, assign it the group chat, and the standard configuration. The AutoGen Group Chat Manager is a chat manager agent that orchestrates group chats with multiple agents, ensuring efficient communication and task distribution among them. Now we can initiate the chat, the manager is responsible, and we give it a precise process to follow. First, the damage analyst should identify the car based on the image, what brand it is, and what the requested spare part is. To do this, it should check if anything in the image is central, stands out, is broken, or is missing, for example, stolen tires. In the second step, the inventory manager should verify that the spare part is actually available, meaning it needs to check the inventory database. In the third step, the customer support agent should then compose an email, and step 4 consists of concluding the process with the word terminate. We also give it the image reference, which is a picture of a broken Tesla display. Let's give it a try. The process has now begun. The user proxy is transferring the task to the chat manager. Based on the image name, the inventory manager assumes it's a screen and confirms its availability. In the next step, the customer agent composes an email. Already pretty impressive, right? Now, however, we actually want to use a picture from which the name does not indicate which part is damaged. Here we have a nice picture of a broken Tesla bumper. Let's put our system to the test with this image where the file name doesn't reveal any details about the actual damage. Again, the inventory manager will say that the spare part is available. That's no surprise because it has no access to the database yet. Unfortunately, we see that the email does not directly refer to the part because it simply doesn't know what it is. We want to improve that by creating an agent who is capable of recognizing images. For this, we create the agent damage analyst. To engage with a multimodal conversible agent, we first need to import it from AutoGen. Multimodal conversible agent can process images with GPT-vision. It gets the persona that it is responsible as a damage analyst for precisely describing the image or its contents. We provide the damage analyst with a system message instructing it to accurately describe the contents of the image. The message emphasizes the need to respond only with what is visually evident, without incorporating any additional information or making assumptions. We give it the configuration for GPT-4 Vision Preview and set the max tokens to 300 so that it can create a detailed response. Then we add the new agent to the group chat, and now we can start again. We see that the damage analyst has wonderfully recognized that it is actually damage to the bumper and that it also sees scratches, etc. The inventory manager acknowledges and confirms that it sees that the bumper and other parts of it are affected and says that all parts are actually available. Now the customer support agent can also compose a suitable email referring precisely to these spare parts. In the upcoming parts of our tutorial, we will further enhance our AutoGen setup. We will provide the agents with access to a real database to check the availability of spare parts. This will be seamlessly integrated within an auto repair shop's webpage. Additionally, we will enable the system to actually send the composed emails to clients, completing the circle of automated customer interaction and service facilitation. We pick up right where we left off, because who needs new beginnings anyway? First, to access the inventory, we create a file named inventory.py. In this file, we import SQLite 3, which will represent our database. To streamline the video, I've already prepared the methods for communication with the database and will paste them in. The first one, setup database, is responsible for creating the database and its tables. As you can see, it first establishes a connection to inventory.db. Think of it as dialing into a secret channel. Once connected, it wields a cursor, the magic wand, to interact with our database. The setup database method proceeds to execute an SQL command. This command is like an instruction that tells the database exactly how we want to set up our table, specifying columns for part and ID, part and name, quantity, and price. After executing the command, it prints a simple message saying "Table created successfully" to let us know everything went as planned. Moving on to the insert sample data method. The method reconnects to our inventory.db file and then inserts a list of items into the table. These items are parts, such as Tesla windshield and Porsche tire, each with an assigned quantity and price. Finally, getInventory is our seeker. It quests into the depths of the database, retrieves all the rows of data with a well-crafted query, and then maps them into a list of dictionaries, because who doesn't love a good map? It's here that each part is accounted for, ready to be displayed, used, or admired. Now we can test the functions and even insert data into the database. We call the setup database and insert and sample data functions in succession. We see a message that the tables were created successfully. We can now actually make queries against the database using the SQLite 3 console program. And it looks good. We are retrieving the data from the database. Now let's put our getInventory method through its paces. And it looks promising. The method successfully retrieves all the data from the database. Next, we need to enable what's called function mapping. The first step is to create a declaration of the method. This ensures that the AutoGen agents know the name of the method and what it does, and if in doubt, with which parameters it must be called. It's all quite straightforward because we pass no parameters. We want the whole data banquet, not just the appetizers. We import the method and its declaration into our app.py and extend the configuration of the inventory manager so that it knows this function exists and what its purpose is. The user proxy gets the exclusive right to execute the method, because too many cooks will spoil the database broth. For this, we map the function using the function map keyword. It's crucial to note that in our scenario, the inventory manager is aware of the method's existence, but doesn't execute it directly. Instead, it recommends that the user proxy execute the method, and then uses the results to formulate its response. Finally, we ensure that the process is properly terminated when one of the agents returns terminate. The isTermination message method checks if the provided data contains a non-empty content field and returns true if terminate is found within this content. We put our creation to the test and voila, the user proxy receives the return value, no applause necessary. Let's take a moment to celebrate this achievement. We now have an agent capable of accessing databases, opening up a world of possibilities for us. But there's a plot twist. The process ends too soon, like a detective novel missing the last page. It seems that the customer support agent is terminating the process before it's completed. To fix this, we remove step 4 so that the terminate message is only executed when the customer support agent has formulated the email. We try again and we see that the email was successfully formulated, and this time with real data from the database, including the price of the spare part. In this update to our AutoGen series, we showcase a significant advancement, equipping AI agents with email functionality. This integration boosts our system's communication capabilities, demonstrating a crucial step forward in operational efficiency. We're picking up right where we left off. Now, we're going to create a new file called sendmail.py dedicated to handling our email logic. I've got the code ready, so let's add it in. Our first task is the sendMail method. Let's add the necessary imports to our script. Once we have everything set up, we'll dive into explaining what's happening in this part of the code. This function is designed to send emails programmatically. It accepts 3 parameters: the subject, body, and recipient's email address. Our sender is a placeholder private person with a sample email. The function constructs the email using these details, then connects to Mailtrap's SMTP server for safe and secure testing. Here, the email is not sent to the actual recipient, but captured by Mailtrap, allowing us to test and debug without risking real-world errors. We use environment variables for security, keeping sensitive information like passwords out of the code. Finally, the function confirms the email's successful dispatch. To ensure it works as expected, we'll conduct a test by sending an email with the message, "Dear Mr. X." After running our sendmail Python script, we'll check the mailbox. Perfect. There's a new email in Mailtrap from us to testmail with "Dear Mr. X." This means we're ready to integrate this into our agents. We import the sendMail method right from our Python file. If you're not familiar with services like Mailtrap yet, it's essentially a fake SMTP server designed for development and testing purposes. What makes Mailtrap so convenient for developers is that it intercepts and stores emails sent by your application in a safe testing environment. This means you can test email functionalities without the risk of sending actual emails to real users. Since this part is functioning correctly, we're now ready to integrate it with our agents. To do this, we'll directly import the sendMail method from our Python script, making it accessible for agent use. But we're not done yet. We need to add a method declaration to guide the agents on how to use sendMail. This gets imported too. This is a function description that guides our autonomous agents. It tells them about the sendMail function, specifically designed for sending emails via SMTP. This description is vital as it outlines the function's purpose, the required parameters such as subject, body, and recipient's email address, and their data types. This clarity enables our agents to understand and execute email sending tasks with precision. Now, it's time to empower the user proxy with this method, enabling it to send actual emails. We also inform the customer support agent about sendMail, so it can recommend its usage to the user proxy. We add sendMail to the functions array. We tweak the system message so that it not only drafts, but also sends emails. The process is adjusted so the agent not only writes, but also dispatches the emails. With everything in place, let's put our new logic to the test. We reboot the Python app and observe. The damage analyst accurately identifies the issue. The inventory manager checks the availability of spare parts. The customer service agent has prepared a detailed email. But there's a hitch. It doesn't have the customer's email address. For now, we'll manually add the customer's email in the prompt. This will eventually become a part of the customer's initial message to the agents. We add bobfood.de as the email and give it another go. The process restarts, and we're hopeful the email will be sent this time. It looks promising. We've got a notification that the email is on its way. Lastly, we check our mailbox. And there it is, a new email. It contains the message for the customer, including the price for the new spare parts as per the database entry. And that's a wrap, a successful integration. We've made exciting progress. Our AutoGen agents are now empowered with email functionalities, marking a major leap in their autonomous communication capabilities. Welcome to a groundbreaking episode in our series. Today, we're introducing Flask, a powerful tool for web development. We're taking a big leap by connecting the AutoGen group chat directly to a real web page. This integration will showcase how we can bring the power of AI-driven chat into the interactive world of web applications. We're picking up right where we left off last time. First, we need to install Flask. Flask is a Python standard for creating web applications. We'll import Flask, then render template and request from Flask. Next, we create a new web application. And we'll set up our first route, the index route, to deliver the index.html. Here we allow two HTTP methods, get and post. Get is used to display the page, and post actually triggers the initial chat method. To check if everything's working, we'll just render the template for now. Now we can instruct the web server to start. We check if the script is being run directly, ensuring that the code block that follows only executes in this direct run scenario and not when the script is imported elsewhere. For this, we check if the name equals main and then start the server in debug mode. To prevent the proxy from triggering the chat immediately upon starting the web server, we put it in an initial chat method. We'll create the index page in the templates folder. Here we'll first create a very simple web page with the words "Hello World" to see that our Flask web server is correctly delivering the pages. We can already test it. And we see that with just a few lines of code, we've already transformed our console application into a web application. Now we need to connect the website to our group chat. For this, we adjust the index route. Our index route gets two tasks. If it's a post request, we want to trigger the execution of the group chat. For this, we first retrieve the entered image URL, customer email, and customer message. Then we call the initial chat method with exactly these parameters. Now, of course, we need to adjust the method accordingly to accept these parameters. We can also adjust our prompt to use the past parameters instead of hard-coded values. Now let's improve our web page. I've already prepared the code for the index HTML, so we don't have to spend much time here. Our web page starts with a captivating hero image, leading into a streamlined form. Users have the convenience of entering their email, an image URL, and a descriptive message for assistance. In future enhancements, we plan to upgrade the form to allow direct image uploads, further simplifying the user experience. And we'll create a result page in the same templates directory. I'll directly paste the code from the clipboard. Our page not only features a hero image, but also displays a warm thank you message. To display the hero image on our pages, we first need to place the image in the static folder. This step is necessary because Flask, our web server, uses this specific directory to serve static files like images, making them accessible in our web application. Organizing our images is key for our Flask application. We store them in a dedicated images folder within the static directory. And we see that the page already looks quite good and our form is displayed correctly. Before we test the form, we need to specify that the result page is displayed correctly after sending the page. For this, we adjust our index route accordingly. And render the result page template in case of success. But now I realize that we've got the logic reversed, because we actually want to display the result page after successfully executing the group chat and otherwise the index page. Now we can test if we've done everything correctly. We reload the page and start filling out the form. We deliberately don't give any hints about what's broken because we want to see how our group chat identifies the necessary spare parts based on the image. We already see in the background that the group chat has started and an email is being sent. We can now check this by going back to the mail trap page. And we see we have a new email in the inbox, and indeed, customer support writes to us that the spare part is available for €2,000. Today, we're diving into constructing an interactive chat from scratch, bolstered by an API powered by AutoGen agents. Part 1 will focus on building the chat flow, while Part 2 will center around developing the API. This streamlined process is easy to follow, and you'll have access to the source code, setting you up perfectly to create your own AI-powered agent solutions. Stay tuned until the end of this video, and we'll reward you with a special surprise as a thank you for joining us on this journey. Alright, let's embark on our digital odyssey with VoiceFlow, our trusty sidekick in this adventure. Think of VoiceFlow as our magic wand, ready to conjure up powerful chatbots for websites in the blink of an eye. First up, we're creating a new assistant. Let's name this digital wizard and teach it to converse in English. We're greeted with a setup wizard, but hey, we're explorers. Let's start from scratch and unravel the mysteries ourselves. Our first act of magic. Conjuring a text block to welcome visitors with a message that's warm, inviting, and possibly a bit cheeky. Next, let's add a dash of personality with an image, maybe something that shows off our team's charming faces. It's all about making a great first impression. Now, it's time to ask our guests how we can be their digital superhero today. We're setting up response buttons for now, but soon we'll dive into the ocean of free text responses and fish out their true intentions. Let's offer two magical portals. I want to buy spare parts and I want to lodge a complaint. For now, we'll travel down the spare parts path. We're sidestepping the complaint department. Let's keep things positive and focus on helping our visitors find what they need. Time for a test run. We're greeted, asked for our heart's desire, and voila, a follow-up question appears as if by magic. Let's capture the visitor's wishes like a genie in a bottle using the capture block. To see if everything works, we'll have it output this once. This is only temporary for debugging, and we will remove it later. We test again, but this time not the entire flow, but we can press the little play button on each block, and then it will execute from that point. And we see that it works perfectly, meaning the user's input is displayed to us. Now in the next step, we want to not only display the user's request, but actually send it to our API endpoint. For this, we create a new block, and this time we choose API from the list. This API is a crystal ball, revealing availability and prices with the help of our autonomous agent elves. I have already created a small endpoint and deployed it on render, and we can test what the return result is based on this last input of the user. In just about 5 minutes, we're going to build this API endpoint from scratch. A nicer way to specify the required query parameter is not directly in the URL, but in the headers. Now we test the request and give it a try parameter windshield, and we see our response, and indeed we see that it is in stock. We can then formulate the response to the user based on this successful API access. For this, we choose an AI block, where the response can be answered using a language model like GPT. We enter a prompt, just as we would do in the GPT interface. We tell it to answer the customer's question. For this, we give it the user's last input and also the response from our API endpoint. But first, we need to capture this magic in a bottle to refer back to it, and that's our next trick. For this, we have to go back to our API block, and there we have the menu item capture response. There we can give it the exact name of the JSON key, and to find this out, I run the request again. The key is spare parts. Now we can access it and assign its power to a variable. We can then access it via response point spare parts and assign the value to a variable. We name this variable server response. We can then use this new variable directly in our prompt. Furthermore, we want to give GPT some output instructions via a system message, especially to define the format of the response. So we tell it to please respond in the following format. The item is currently available for a certain price, for example, X dollars. Now we can actually test our flow completely. Building a full-fledged chatbot with API access in 5 minutes is like speed dating with code. You hope for no awkward mistakes. We say we want spare parts. It asks us what exactly we want. In this case, we want a windshield again. The API request is made, and we see that the item is currently available and can be converted for $200. Now we can prepare the chat itself for our website. For this, we give it a brand image and an icon. And we can now test the result in a new tab. Basically, we have two options here. We can have a single page, or we can also overlay it on an existing page. We go through the process again. This time I'm looking for a Tesla display. And we find out that the Tesla display is available and can be provided for a price of 349 euros. Now we can make a few small improvements. First, we don't want the user's input to be displayed again one-to-one. So we remove this block and connect it directly with our query to the API. Then we make it a bit more compact. And I had promised that we would also find a solution so that you don't have to press buttons. Let's first understand the challenge at hand. As it stands, users can express their intent for spare parts only through button selections. However, in a truly convenient chat experience, users might type something like, "I'm searching for a spare part for my Tesla." Ideally, our chatbot should recognize and understand such sentences. Sadly, this level of comprehension isn't part of our current setup. For this scenario, VoiceFlow offers intents that function like virtual buttons, intuitively deciphering the user's direction of inquiry. The more examples we provide of potential user queries for this path, the better VoiceFlow becomes at grasping the customer's intention. We let GPT generate even more, teaching it the art of anticipation. Okay, let's see if it works. This time, I'll type that I need some spare parts. Alas, our digital genie seems puzzled. We need to prepare it better for its task. With a click on Train Assistant, we hope to improve our spell's understanding. We try again, asking for a few spare parts. Success! Our digital genie inquires further. We request a windshield, and the response is swift and accurate. But now, let's delve into the wizardry of building the API that conjures these responses. As promised, we're beginning from scratch. Initially, we set up a virtual environment, a crucial step for cleanly separating our dependencies. Activating this environment is our next move. We then create an app.py file. Our first task is to import Flask, but before that, let's install it along with AutoGen. Having installed the packages, we're ready to import them. From Flask, we import Flask, JSONify for JSON conversion, and request. For AutoGen, we only need the core AutoGen module. We proceed to establish a new Flask app and create an endpoint that's ready to run. We then define the function that's triggered upon endpoint activation, naming it spare parts for clarity. Next, we fetch the parameter from the request, specifying the parameter name query. We start with a simple return to test functionality, giving back a JSON with the query. Now it's time to set up the server. This ensures automatic launching with the Python file. We use the standard check for main to make sure the script runs only when directly executed. We initiate the server in debug mode for clear output visibility and bind it to the IP 0.0.0.0 for external accessibility, choosing port 80. We're now ready to test the server startup by running the Python file. Once started, we can easily test our get endpoint in the browser. Upon testing, we observe that spare parts is correctly returned. Adding a parameter results in its return as well. With this success, we move on to integrating AutoGen, starting with setting up the configuration. We ensure the config file is in the same directory. This file allows us to specify the language models available, keeping it simple with just one model, GPT-4, and including the necessary API key. In my case, I won't add the API key directly because I prefer to set it as an environment variable. Now it's time to create our first assistant using Assistant Agent. We give it a name and configuration using the config list we just created. We also need a user proxy to mediate between us and AutoGen in this group chat setup. We then set its human input mode. AutoGen offers various interaction modes. We opt for Never mode for fully automated agent operation upon request receipt. It's crucial to specify termination conditions to conclude the process. We terminate the process when an agent replies, "Terminate." Everything is now in place to start the chat. We initiate it with the initiate chat method, providing the assistant and a relevant message. Our goal is for the assistant to provide spare part availability and pricing, concluding with terminate. As it's not yet database connected, we allow it to freely find information. We pass the request and specify the desired output format. We're now ready to retrieve the response, accessible through chat message from the user proxy, specifically from the assistant. Choosing the second message, as counting starts from 0 in computing, we get its content. With the response in hand, we're set to return it. That concludes the setup. Now we can proceed to test the code. Let's position both windows side by side. And input windshield as a parameter. We notice an issue with the API key, which we'll promptly address. Correcting the API key issue, we see the chat initiate successfully. The system plans to check availability as expected, but we need to ensure it doesn't execute unwanted code. To ensure the agents refrain from utilizing code for the time being, we need to explicitly instruct them. Once we've updated the prompt with these specific directives, we can proceed with another trial run. Excellent! This is precisely the output we were aiming for. Following our specific instructions, the response now perfectly matches VoiceFlow's expectations. Now, if we revisit the API request within VoiceFlow, we'll notice that we've received precisely this response. This observation effectively closes the loop in our process. Now, one might argue that employing AutoGen for generating such random responses seems like overkill, but bear with me. What we've done here is lay the groundwork for integrating our group chat agents from the last part of the series, which are capable of accessing an SQL database and sending real emails. In our next video, we'll bring these elements together and truly make the magic happen. Picking up from where we left off in part 4, we begin by establishing a route accessible by VoiceFlow. We name the route run and link it to the spare parts method. Next on our to-do list, wrangling the get parameter named query to kickstart our chatty adventure. Our next move involves crafting a method aptly named initiate chat VoiceFlow. This method takes in the query parameter and springs the chat into action. Reusing the prompt from our VoiceFlow REST API example, because why reinvent the wheel, especially when it's a perfectly round one? The only notable difference here is that we will obviously not use the sentence that allows him to make things up anymore. Once more, we extract the fruits of our group chat labor through the mystical realm of user proxy chat messages. We then dutifully return these messages, now on a mission to transform them all into the JSON promised land. To achieve this, we utilize JSONify, though it still requires importing. And now, for the grand unveiling of our shiny new endpoint, drumroll please. We observe that all the messages are successfully retrieved. Now comes the detective work, sifting through the message haystack to find that golden needle, the last message from our customer support agent. This is necessary because VoiceFlow is unable to process arrays in JSON structures and can only manage simple key-value pairs. Consequently, we craft a new function, concat assistant message, tasked with filtering these specific messages from the customer support agent and outputting them as a string. For this, we iterate through all chat messages, and if the message is from the customer support agent, then we concatenate them into a large string. In this process, we extract the content of each respective message from the content field. Finally, we return these messages and employ them right here at the endpoint. All right, time for another go. And oh no, a wild error appears, plot twist. And I already see a small typo has crept in. Clearly in line 13, our intention is to extract the content from the filtered message, not from all messages. After fixing the typo, we try again, and now it looks good. Here's the output, an old friend from past episodes, but this time with a twist. It's the real deal, straight from the agent's database detective work. Testing it again with a different search term, we can observe in the group chat that the inquiry was indeed verified in the database.